what is the most important recommendation when you try to create the backbone, when you try to organize the backbone? What is the consideration number one that you need to keep in mind?
How many you're connecting together?
Okay, how many equipments I am going to connect? That's number one. What is the maximum amount of equipments allowed? The maximum amount of devices allowed are 50 devices. Okay, what other consideration you need?
Electromagnetic interference.
Correct, electromagnetic interference. Tomorrow I am going to bring the EMI device, and we are going to check what happens if I am close to a generator, what happens if I am close to a motor, what happens if I am close to some equipment. Give me example of equipment that produce a lot of EMI, electromagnetic interference.
AC motors, chargers,
AC motors, generators, battery chargers, inverters. For that reason, it's important to buy that equipment. Tomorrow I'm going to bring that equipment. It's that one. To check if you have excessive electromagnetic interference. And the recommendation is, okay, be separated from those equipments that produce a lot of electromagnetic interference. That's another important recommendation. The number of devices, the electromagnetic interference. Other important consideration is where is coming the power? The power for the backbone. From what group of batteries will be coming the power for the NMEA backbone? Remember that in a typical boat, how many group of batteries we have? 5, 6, depending of the boat, no? In your boat, how many group of batteries you have?
3.
3 in your boat?
That's the average.
Yeah.
2, 3, depends on the
Okay.
size.
Bigger boats, they have more group of batteries. Okay. What group of batteries is not recommended to supply power for the NMEA backbone?
Cranking?
Excuse me?
Cranking?
Cranking batteries, generator batteries. No good. What about the house battery bank? It's good. In some boats, in some medium and big boats, they have another small group of batteries, creating a small battery bank, electronics battery bank, and that battery bank supply power exclusive for the electronic devices. Anybody follow me? In other boats, the engineers, the technicians, they create another DC sub-panel, like this, with power for all the electronic devices. That sub-panel depends on the main DC panel. Anybody follow me? In the main DC panel, you remember the main DC panel that we wire? Yeah, with the lights, bilge pump, all of those devices. One breaker in the main DC panel is electronics. When you activate that breaker, you send power for this sub-panel. That clear? In other boats, they have a separate group of batteries exclusive for the electronics. Right? All right. Consideration is where is coming the power? Never use the cranking batteries. Why the cranking batteries are not good for those electronic devices?
Because they drain too quickly.
Excuse me?
They drain too quickly.
This is one reason. They drain quickly.
They're not made to give up control.
But the main inconvenience with those batteries, the cranking batteries.
Too much high amperage.
Okay, high amps. Okay, but this is not the main the main inconvenience with those batteries.
They cannot discharge deep enough.
Excuse me?
They cannot take a deep enough discharge.
No.
It could mess up some of the computers and
The cranking batteries produce too much noise, too much interference. and affect those delicate devices. You remember during the cranking of those big diesel engines, how many amps are flowing? How much is the voltage drop? You remember? Yeah? The cranking batteries are no good for this purpose.
Is 3 volts drop or is it more than that?
3.5.
It's 3 volts.
Yeah. All right. Okay. Never use that. Mr. Lopez, I have a small boat with only one outboard. This is a special situation. This is a special situation. You only have one battery, and you don't have any other option. That battery is for motor, for house, for everything, because it's a small. The dinghy boats, no? Some dinghy boats they only have. But we are talking about a medium boat, big boat, or mega yacht, no? Everybody follow me? Okay. How many types of cables are commonly used in the organization, the creation of the NMEA backbone? 3.
Small,
Mini, medium, and micro. Mini, mid, and micro. What is the big one? In diameter and in capacity. Mini, mid, or micro? What is the big one? The mini is the big one. And the smaller? The micro. Okay. Is the big one in diameter, and also is the big one in capacity to allow the flow of electrons. The mini cables allow the flow of 8 amps in the backbone, and the micro 4 amps in the backbone. This is one important consideration that you need to keep in mind. In the backbone should be flowing no more than 8 amps. No more than 8 amps. No more than 8 amps. How can I limit that amount of amps in the backbone? How can I limit? Later we are going to talk about that. With fuses connected in line. Those fuses. This is the power cable, and with those fuses, 8 amps, I limit the amount of amps flowing in the NMEA backbone. This is the most important consideration. Later we are going to talk about that. Okay. Okay, look at this typical NMEA backbone. The cables, the big cables are the mini cables. They connect this bus bar with this, and the micro are those going into the equipment. Other going into the equipment. Those are the drop lines. In the future, we are going to use those micro for drop lines, and we are going to use those mini to connect the bus connectors and create the backbone. I have another bus connector here, or if I don't have a bus connector, I have a lot of T's connected together, and I create a bus connector, you know? One here, other here. What is the maximum distance in between this terminal resistor, and the other, and in the other end? If I use mini cables, what is the maximum distance allowed? What is the maximum distance according with the book? 250 meters. If I use micro cables for the backbone, in between terminal resistor and terminal resistor, what is the maximum distance allowed? With mini cables, the capacity is 8 amps. With micro cables, the capacity is 4 amps. Remember, micro cables are used to drop lines. Drop lines with micro cables. What is the meaning of drop line? It's the line in between the sensor and the backbone, or the equipment, the display of the equipment and the backbone with micro cables. What is the maximum distance of a drop line? 6 meters. is the maximum distance of the drop line. My friends, the people think that electronics, marine electronics, is only the connection of the radar, the GPS, the transducer, the fish finder, the radio in a backbone. But marine electronics is more than this. It's the integration of all the equipments, all the devices in the boat in the backbone. It's more than this. It's the integration of all of them. It's the integration in the backbone of the engines, the integration in the backbone of the air conditioning equipment, the integration in the backbone of the water makers, generators. All the devices inside of the boat can be connected, can be integrated in the NMEA backbone. For what purpose? What is the idea? To administrate all of them in your cell phone. If that equipment, if that motor, if that generator, if that device is connected to the NMEA backbone, you can start in your cell phone your engines. You can administrate the temperature of the air condition in your cell phone. You can check the cameras in your cell phone. You understand? If everything is integrated, you can administrate in your cell phone or in the main screen, in the pilot hand, everything. You don't need to go to the engine room to start the generator if the generator is integrated to the NMEA backbone. Everybody follow me? This is why it's very, very important. Integrate everything in the NMEA backbone. Some years ago, you remember that I explained that some years ago, each manufacturer speaks your own language. For example, this one was the first approach to a backbone. This is the control, and this is the backbone exclusive for engines. You can connect here 2 engines or 4 engines, and this is the terminal resistor of this backbone, and this is the control. That was the first approximation. This heavy and those type of connectors. Yeah, that was the first approximation. But that one was exclusive for engines and transmissions. That's it. Oh, can I connect here the generator? Can I connect here the air conditioner? No, because this is private protocol. Private protocol. Okay, that was the first approximation. You remember, Captain, those type of controls? No, there are a lot of boats with this configuration. Some years later, they create the fly-by-wire. In the course of gasoline, in the course of outboards, we are going to learn with more details about the fly-by-wire. We have a chapter dedicated to controls, and we are going to try to understand what is the meaning of this system, fly-by-wire. And this one is connected with other small bus bar, and that one can be integrated with NMEA. Okay, that was the next approximation. Oh, I can integrate here 5 engines. No? With this control. This is the fly-by-wire, and we are going to talk later about this type of configuration. And with this one, I can connect engines and gauge, the gauge per each engine. And that one connected with this, and this one to the NMEA backbone. All right. And today we have excellent protocols like this that you can connect directly the engine to the NMEA backbone. Directly the engine and the gauge to the NMEA backbone. In other words, in the main screen, you can administrate engines, generators, if they are connected directly in the backbone, directly in this backbone.